Welcome back to the decision tree module. Let's get our hands dirty and learn how to build decision tree models in Python. So first, we'll import the required libraries, pandas, numpy and matplotlib here. So let me just go ahead and do that. And this line here, %matplotlib inline, ensures that the graphs that we'll be plotting later are displayed in this Jupyter notebook itself. We'll be working on the Titanic dataset, which we've already seen while implementing logistic regression. Here, we'll be using a clean dataset. It does not have any missing values. All categorical variables have been converted to numerical using the one-hot encoding, as the sklearn models only take numerical inputs. We've discussed this before as well. You can download the clean dataset using the link we've provided below this video. So here I've read the data using the read_csv function of pandas. And let's now look at the shape of the data. Most of us are already familiar with this. We have 891 observations and 25 columns of variables. To look at the variables, let's print the first 5 rows of the data using the .head function. And here we go. Remember, we used one-hot encoding. I've mentioned this. That's why we have so many variables here. In this problem, survived, the first column here is the target variable, where 0 means that the passenger on board the Titanic did not survive, while 1 means that the passenger did survive. And you can see that all features are converted to numbers as well. Let's check if there are any missing values in the data. We've already cleaned the data set, but it doesn't hurt to just verify that. We've used the .isNull.sum function here, which returns a number of missing values in each variable. And as you can see here, it's perfect. There are no missing values. You can also see that encoded variables like pclass_1, pclass_2, and so on are in this data set. Now, do you recall that to build any model using sklearn, we have to specifically define the target variable and all the independent variables? For this Titanic problem, the target variable is survived, which we'll store in a variable called y. And to store all the other variables as independent variables, I've done that in a variable called x. I've dropped the survived column here from the data since we've already stored it in y here. Alright, let me go ahead and run this. Now, to validate how a model will perform on unseen data, we need to create a validation set, again like we've discussed before. Now, to create this validation set, we will use the train test split function of sklearn's model selection module. So I'm going to go ahead and import that. Alright, perfect. Here I've called the train test split function. Setting random state as 101 will make sure that every time you run this code, you will get the same observations in the train and validation set. Stratify is equal to y will make the similar distribution of classes in both training and validation set. And I've given the test size as 0.25, which means that the training data set x_train will contain 75% of data, whereas the test will contain 0.25, which means that the training data set, which is x_train here, will contain 75% of the data, while validation will contain 25%. Let's verify the distribution of classes in both training and validation sets. The value counts function, which we've just implemented here, value_counts, returns the count of all classes. And normalize is equal to true here will return the percentage. So in the training set, around 61.67% are zeros and 38.3% are ones. Similarly, let's check the distribution in the validation set. As you can see, it's almost similar. Around 61% are zeros and 38% are ones. So using the stratify is equal to y, we can make the distribution of classes similar in both train and validation set. Let's check the shape of the train and validation set as well. So there are 668 observations in a training set and 223 in the validation set. Alright, now let's build the decision tree model. Here I'm not focusing on creating different types of features and building best models. Instead, I want to explain how to build a decision tree model and change the parameter to have different models post looking at the model result. Remember, this is a classification problem where we have to predict whether a passenger on board the Titanic will survive or will not survive. That's why we'll use the decision tree classifier. Let me import it from the tree module of sklearn. Had it been a regression problem instead, we would have used the decision tree regressor. And you can import it like this. I'm going to go ahead and do this even though it's not relevant for our problem, just to give you an idea. We'll now call the decision tree classifier model and save it as a dt underscore model. Again, we're using random state. It ensures that every time we run this particular model, we will get the same results. Here I've set random state as 10. You can choose any integer value here as you see fit. So I'm going to go ahead and run that. Let's now fit the decision tree classifier. We'll use the dot fit function and pass the x underscore train and y underscore train, which remember are the independent variables and the target variable respectively for the training set. Here you can see that the default criterion of a decision tree classifier is Gini. You can change it to chi-square as well, like we discussed in the previous videos. We've also seen things like max depth, max features, etc. So these are all set to default here since we have not played around with them. Let's now check the performance of the trained model first on the training set and then on the validation set. Here, the dot score function, as you can see here, will return the accuracy of the model. Wow, our model is 98% accurate on the training set. Perfect. But wait, let's check the performance on the validation set before we get excited. It's dropped down to 75%. You can see that the training and the validation accuracy are not in sync. Training accuracy is very, very high, and the validation accuracy has dipped as compared to the training accuracy. Now, we can use the predict function, which will predict whether a passenger survived or not on the validation set. X underscore valid as I've passed here. Let me just do that. Here we've made predictions for all the observations in the validation set. Apart from predicting the class, we can also predict probability for both classes 0 and 1 using the predict underscore prob a function. So I'm going to go ahead and run that. Here we go. So what do you think this is? Here the first column, this one, is for class 0 and this one is showing the probability for class 1. I can also use different thresholds to decide the class of observation. When we use the predict function, it takes 0.5 as a default threshold. So let me just play around with the threshold and see if we can get the accuracy up. So what I'll do is I'll take the first column here, predicting the probability is a 1. So let me go and do that and I'll save it in a variable we'll call y underscore pred. Alright. Now I'll set the threshold to 0.6. Remember it was 0.5 previously as it was a default one. So let's see what happens when we take a threshold of 0.6. So when I say 0.6, I mean any probability less than 0.6 will go into 0 and any probability more than 0.6 will be taken as 1. So let me go ahead and run this for loop. Let's import the accuracy underscore score metric and check the new accuracy. It's actually coming out to be pretty much the same. This is just to show how you can change the threshold. It's not always necessary that after changing the threshold, the accuracy will increase. In some cases, that accuracy might decrease as well. So far, we've seen that the training and validation accuracy are not in sync. In the previous video, we saw many parameters that can be used to optimize the performance of decision trees. We saw those default parameters here as well. So let's use some of those parameters and try to optimize the performance of our decision tree. Let's look at the max depth parameter. If you recall, it tells us the length of the longest path of the tree. Here, I've taken the range of max depth from 1 to 10. So we will train the decision tree model 10 times and change the parameter max depth from 1 to 10. For each model, we will store the training accuracy and the validation accuracy in the empty list which I have defined here. So let's run this and store the values. Now let's create a data frame from the values which we got in the previous cell. So let me do that and print out the first 5 rows of this data frame. Here we go. You can see that we have the training and validation accuracies corresponding to a set of range of max depth. Let me plot these values here. And this is the plot we get. As you can see that when we had a max depth of 1, both the training as well as the validation accuracies were less. So keeping a lower value of max depth did not allow the model to learn the patterns. And hence we got very low performance. Or you can say that it is a case of underfitting. As the max depth now keeps on increasing, both the training and validation accuracies are increasing as well. The magnitude of increase in training accuracy is higher as compared to the magnitude of increase in the validation accuracy. In this particular case, when we look at the max depth of 8, it is producing the highest validation accuracy, and hence we can set the max depth as 8. It drops off the board here, so yeah, that is why we're taking 8. Similar to what I've done here, you can try with different parameters as well. And I strongly recommend you to find the optimum value of other parameters like max leaf nodes, minimum sample split, min samples leaf, etc. So here I found out the optimum value for an individual parameter. You can try it with a combination of parameters as well. You can use multiple for loops and then try to find the best combination of parameters. There's actually one more technique that automatically does this for us, which is grid search. It helps us to find the optimum value for a combination of parameters. And don't worry, we'll discuss more about this technique later in the course. For now, I suggest you find the optimum value of parameters on your own. It's a great learning exercise. Let's use the max depth of 8 and max leaf node as 25 here and train the decision tree model again. Let's see what happens. Remember, random state will make sure that we get the same result every time we run this code. So I'm going to go ahead and run this. Let's now fit the model by passing the x underscore train and y underscore train, which are the independent and dependent variables respectively for the training set. Let's now check the score on the training and the validation set. So we get a training accuracy of around 88%. Let's see what we have in the validation accuracy. Alright, we have 81%. Now we can say that the training and validation accuracies are more in sync as compared to what we got in the beginning. Previously, the training accuracy was 98.8% and validation accuracy was 75%. And hence they were not exactly in sync. But when we look at these two accuracies now, they're far more in sync, and we can say that the model we've just created is a more generalized model. You can play around with different parameters and then choose the one which gives you the best results. As I've discussed in the beginning of this module, I will show you how to plot a decision tree. So let's get to it now. Let's plot this tree that we've just recently trained. To do that, we'll have to import the tree module from sklearn library, which will help us to plot the tree. Now you'll need to install the GraphViz library first. I already have this on my system, so I will skip this step, but you will need to do this before you can get to the plotting part. In the tree module of the sklearn library, there's a function called export underscore GraphViz, as you can see here, which helps us to export the trained tree. Let's have a look at the parameters of this function. First of all, we have to pass the model name, which is dt underscore model. Then the out underscore file parameter specifies the name of the output file. This function returns the image in dot format, and that's why I've set tree dot dot here. Then the feature underscore names defines the names of the features of variables. So we've passed x underscore train dot columns here, which returns the names of the columns. Max underscore depth defines the maximum depth of the representation. Don't confuse it with the max depth of decision tree model. In this instance, max depth would only print the decision tree till the specified depth. However, the model will be trained on the depth that we have specified while training the model. Very important to note this difference. And filled is equal to true will paint nodes to indicate majority class for classification. Don't worry, we'll see that shortly. I'm going to go ahead and run this. Alright. As the above function returned the image in dot format, we need to convert it to a readable format. So in our instance, we'll say the PNG format. This command will convert the image to the PNG format and save it right into our current directory. Alright. So let me read this image and plot it here. As we specified, the max depth is 2. The tree only till the depth of 2 has been printed. You can increase the depth as well to plot deeper trees. So let me just take the max depth here as 3 and show you the difference. So we'll run this again, and here we go. See, the max depth is now 3. Alright. So in our tree, the first split here was based on whether the passenger is male or not. The Gini for this split is 0.473 and there are a total of 668 samples. After the first split, there are 247 samples in the first node. That is, there are 247 females and 421 males. Then the node on the left is further split based on the P class. As you can see here, P class underscore 3. And the right node is split on the fair. This is how you can interpret the decision tree. There are tons of applications of decision trees. It ranges from fraud detection, credit risk, loan default, employee attrition, customer churn, to regression problems like predicting sales of a retail outlet or frankly any other business, the number of bikes rented, etc. There are so many applications of decision trees. So, in this module, we learned what a decision tree is, what pure and impure nodes are. We learned different terminologies related to decision tree like the root node, leaf node, branches, and much more. We then discussed how to select the best split point in decision trees and saw different algorithms like Gini impurity, chi-square, reduction in variance, information gain. Then we saw how we can optimize the performance of a decision tree. And finally, in this video, we implemented decision tree algorithm in Python and saw how to plot a decision tree. A really fascinating and interesting module. Thank you.